Next to forming an excellent name for a metal band, the abstract factory is also a commonly used design pattern. Before we start discussing the abstract factory, let's go back to the strategy pattern for a bit. A strategy allows us to encapsulate a variation using an abstract strategy class and define the implementations and subclasses. In the sales order example, we saw different implementations for taxes, currencies, languages, shipping, and so on. Somewhere in the code, you still need to make the choice of which specific concrete strategy you're going to use. Where will this selection happen? Where is the switch or the if statement? The strategy pattern separates the selection of the algorithm from the implementation of the algorithm. Normally, you'd expect that the context class will determine which algorithm to use. But there's a few problems here. For one, if you don't watch out, this is going to result in a big switch or if statement containing all the possible choices. And secondly, since context is going to create these concrete instances, context needs to know about the existence of each of these concrete subclasses. In order to keep the abstraction level we introduced with the strategy pattern, we want to separate creating objects from using them. This is where the factory pattern comes in. Instead of a class A directly using a concrete strategy, it uses a factory that creates the desired concrete strategy for class A. Class A doesn't know anything directly about subclasses of class B, but the factory does. And class A uses the factory to create the strategy it needs. If we look again at our e-commerce example, all classes have responsibility. Sales order knows the country and creates the required concrete strategies for tax, currency, shipping, and language. Each abstract strategy class defines the interface that sales order should use, and the concrete strategies implement these interfaces in their own way. If you add or remove concrete strategies, two pieces of code need to be updated. You need to update sales order so that it can create the strategy objects, and you need to write the actual concrete strategy classes themselves. If you add a new currency, for example, orders in the Netherlands now support payment by Bitcoin, you need to add a Bitcoin strategy class, and you need to change the code in sales order so that it creates the strategy for orders in the Netherlands. This means sales order now has two responsibilities: creating these concrete strategy classes and using them. There's a whole group of design patterns that are related to creating objects. The main idea is that you want to separate two responsibilities: creating these objects and using them. In the e-commerce example, the class that creates all the strategies should now know about their specific kinds, but should never use them. A class that uses the strategies, like sales order, shouldn't have to know anything about the types of concrete strategies that exist. We can improve our original example by introducing a factory pattern to produce the actual strategies, so sales order is relieved of that responsibility. The reason factories are used a lot is because they allow for higher cohesion. Cohesion of sales orders should be improved because it currently has two responsibilities: knowing the details regarding taxes, currencies, and languages for each country, and actually dealing with sales orders, calculating taxes, printing invoices, and so on. We'll come back to this example later on. First, another example to show you how the factory works. Suppose that we have an application that displays and prints data. We want it to be able to deal with different resolutions, low and high, and we have to deal with both display drivers and printer drivers. As the basis for dealing with different printer and display drivers, we use the strategy pattern. Create an abstract class for each of these variations, and then have a context class use them. This leads to strong or high cohesion. And if we need to add new printer drivers or display drivers later on, this is easy. We just create new subclasses. But the question is, where are these actual print and display drivers created? Similar to the e-commerce example, you'd expect this to happen in the context class, app control. But this class is also responsible for using the drivers. So let's separate the responsibility of creating and using drivers by introducing a factory. The factory consists of an abstract class with methods that create concrete drivers. Each of the concrete factory is then a subclass of this abstract class and is responsible for creating a particular set of display and print drivers. In this example, there is a low-res factory that creates low-resolution drivers and a high-res factory that creates high-resolution drivers. And both of these factories are subclasses of an abstract factory called res factory. The app control context class only knows about this res factory interface and not about the actual implementations, low-res factory and high-res factory. Here's a quick look at the big picture of how all these objects are related. App control uses print drivers and display drivers, but only knows their interface. It also uses the res factory interface, but it doesn't know anything about low resolution and high resolution factories. Those concrete factories in turn know about concrete print or display drivers. Let's look at a few code fragments to see how this works. The res factory abstract class defines two abstract methods, one to get a display driver and one to get a print driver. The actual concrete factories then return the correct drivers. So the low-res factory returns a low-res display driver and the same for printer. And the high-res factory creates a high-res display driver and a high-res printer driver. You can now even make new factories with other combinations. For example, a high-low res factory that combines a high-resolution display with a low-resolution printer. I leave it up to you to fill in the dots. And the app control class then chooses the right factory depending on the desired configuration. Later on, it retrieves the drivers from the factory and does something with them. As a result, the context class app control no longer needs to worry about creating particular drivers. It simply asks the factory to do that work. So app control's only responsibility now is to choose the right factory. The complexity of choosing actual drivers are now hidden by the factory. For app control, it doesn't matter which combination of drivers it needs to use. That choice is handled by the factory. Also, app control doesn't need to know anything about the complexity of particular drivers. It doesn't matter if app control uses a high-res or a low-res driver because the interface is the same. And when you go back to the e-commerce example, you can apply this exact same principle. In the original version, sales order had to know about details such as that Ireland uses the euro. In a factory approach, there will be an Ireland factory that takes care of these details. This concludes the video about the abstract factory. If you have any questions, post them in the Teams channel of the course. Thanks. Wait, I almost forgot something. A factory joke. So here we go. I was fired from the keyboard factory yesterday because I wasn't putting in enough shifts. Oh my goodness, these jokes are getting worse every day. And we still have quite a few design patterns to go. What did I get myself into? Oh well, thanks for watching and catch you in the next one.